Hello. This is now we are going to discuss about intensity of radiation I, the rate of energy leaving a surface in a given direction per unit solid angle per unit area of emitting surface normal to the mean direction in space. The intensity of radiation is amount of energy that is emitted per unit solid angle per unit area. That area, how that area should be? It should be the normal to the surface emitting from the main surface. That is intensity of radiation. Next, solid angle. Solid angle, we have a how we calculate solid angle is surface area divided by square of the radius. Surface area which is bounded, a curvy surface area bounded with the surface area bounded with square of the that curvature, radius of the curvature. So that will give the solid angle, and these two are the figures. You just go through these two, and here we write only expression for what is intensity of radiation, that is intensity of radiation is dq122, one surface area to the other surface area, by dA1 cos theta into dA2 or 2 dA. So dA from dA1 the radiation is getting emitted and it is about to reach dA2. So intensity of radiation is given with radiation exchange, that is dq1 to 2, surface 1 to surface 2, and this dq1 to 2 is I, that intensity of radiation, into dA1 sin theta dA2 by r2 r square, and dA2 is r square sin theta d theta d phi. This we know from the figure above, just before page. We know that dA2 is. Now you substitute that within the limits. Theta varies from 0 to pi by 2 and phi varies from 0 to 2 phi, and we get a relation, an important relation, that is emissive power is equals to pi into I. Pi times intensity of radiation. Emissive power of a body is equals to pi times intensity of radiation, and we have Lambert's law, or we can call it as cosine law. E theta is equals to En cos theta. It's very simple, just like resolving a vector. E theta in the direction of theta direction away from the normal, we can get E theta is equals to En cos theta. These two are important relations for our further derivations. The last and important main basic thing for radiation exchange between two black bodies separated by a non-absorbing medium. Now we have two bodies, black bodies, whose emissivities, absorptivities are 1. They are separated with some distance, and there is no any other medium which is absorbing the radiation or disturbing the radiation exchange between the two. It means personally they are exchanging their radiation. So we have dA1, dA2, A1, A2, and the surface A1 is at temperature T1, A2 is at T2. The distance between them is R. dA1, dA2 are normal areas, and the angle in which it is taking the radiation is theta 1, and for the body 2 is theta 2. So again we need to determine solid angles for the both dW1, d omega 1, d omega 2, dA2 cos theta 2 by r1 square, dA1 cos theta by r2 square. Now we know the intensity of radiation equation, Q by A into omega. Q is equals to IA omega, and again same thing, when we integrate them with all substitutions, we get a final important factor. Q1 to 2 is sigma A1 T1 power 4 minus T2 power 4 1 by A a1 integral a2 cos theta 1 cos theta 2 d theta 1 da1 da2 by pi r square. So here we have an important factor, we call it as f12, that is shape factor. It is 1 by a1 integral a2 cos theta 1 cos theta 2 da1 da2 by pi r square. That is the shape factor, which is equals to, finally we get a relation q122 is, here we got q221, no q122 only, it's a continuation, and q122 is a2 sigma, or we get to two relations for q122 itself with respect to a1 and with respect to a2, but both are equal. So with respect to a2, it is a2 sigma t1 power 4 minus t2 power 4 1 by a2 integral a1 a2 cos theta 1 cos theta 2 da1 into da2, and this is other shape factor f221 with respect to a2, and we call a1 f122 is equals to a2 f221 is called reciprocity theorem, where f122 f221 is called shape factors, surface factors, view factors, configuration factors. And similarly we have the heat exchange between non-black bodies. Same way we have two different bodies for different emissivities, absorptivities, temperatures T1 and T2s, and we have a relation. Just go through this and you will find a relation, final relations. Q122 is equals to F122 sigma T1 power 4 minus T2 power 4, where F122 is interchange factor from surface 1 to 2. It is an interchange factor. Now Q122 finally it is F122 capital F122 sigma A1 T1 power 4 minus T2 power 4. We know capital 122 is the shape factor, but small f122 is interchange factor, and that is different for different orientations or different shapes. So that is given in this box 1 2 3 4 5. 5 are given, and these are very important for solving the problems. So in the problems mostly we use it's not only one that we can say that we use this only, we use all. For different problems we have different, we need to use a specified one. And this electrical analogy we will see in the next video, and these are very simple topics, just go through this. Radiosity, you have the terminology, and almost we are at the end of our radiation. Just go through the problems, one or two three problems. When you solve, you will understand what is the radiation. Unless you solve the problems, you won't understand the concepts. Radiation shields, radiation shield. What is the radiation shield? The radiation shields reduce the radiation heat transfer by effectively increasing the surface resistance without actually removing any heat from overall system. From overall system it will not remove the heat, but it acts as a shield which will not allow the radiation to pass on to the other body from E1 to E2 or E2 to E1. That is what the importance of the radiation shield. This type of radiation shields we will use where the especially in agricultural fields also we use this radiation shields. And we go through the problems. Say last one is a problem on radiation shield. When you go through all this, solve the problems, go through the derivation parts, don't ignore. Unless you solve on your own, you won't get it. And if you have any doubts, just come to me. We'll discuss. Call me or send me a message through WhatsApp. We will do it. Thank you.